Hey everyone, welcome to this free lesson on the basics of logarithms. You're going to want to pause and try the examples when prompted, and there are always free guided notes available at divideandconquermath.com. Okay, so before we get started, I actually want to review a few topics with you that I think are very important to understand this lesson. So first I want you to find the inverse of 2x plus 8, and then I also want you to graph 3 to the x. So pause the video, look through any notes that you have to, and then hit play when you're ready to see the solution. Okay, so first let's find the inverse here. And if you have no idea how to do this, I actually have talked about this in another video in great detail, so I'll drop a link to that in the description. So first things first, you want to change out the f of x with the y, and then you want to interchange the x and the y as shown, and now we want to solve for y. So I'll go ahead and I'll subtract off the 8, so I get 2y equals x minus 8. And then I divide each side by 2, so I get y equals 1/2 x minus 4. Therefore, now I just rewrite this with inverse notation, so this is 1/2 x minus 4. Okay, so there's the first one. Now, the other one for 3 to the x, so I've talked about this in other videos, so what I would recommend that you do is I would recommend that you just create a table and use the values from -2 to 2. So you can fill all of this out and then plot the points. But what your graph should have looked like is it should have looked like this. So again, if that's not familiar to you, I will drop a link to that video in the description as well. Okay, so now here's kind of where we really get into the meat of this lesson. What is the inverse of 3 to the x? So I actually think it would be best if you took a second to think about this and actually try to find it. You'll hit a stumbling block, so try to find it and then see if you can find that stumbling block. Hit play when you're ready. Okay, so I'm going to go through the same steps that I did in the last example, right? So I set this as y equals 3 to the x, and then I interchange this, and now I'm like, okay, now I got to solve for y, and then it's like, whoa, what? How do I solve that? So you can't actually solve for y. We don't have math for this, so we do not have the math for this yet. So now we need to talk about a new way of actually getting to this when we have y to the x, this y exponent. And maybe just to clear a few things up, because sometimes I do have discussions with students about this. So we don't have like the yth root. That is not a thing that we have. So I've had some people try to get creative with things like that. You also can't like divide out the 3. They've seen a lot of different things, so just as it stands, we just don't have anything for this. But this is where we need what's known as a logarithm. So a logarithm is like a kind of a new concept that's related to working with exponentials. So I'll just write down the definition here. So you want to let x, y, and a be positive real numbers, and a cannot be 1. So then a logarithm is defined as this. So y equals log base a of x means a to the y equals x. So I know this is kind of a strange looking definition, and it's kind of odd that like a logarithm is just something that's defined as exponential, but this is the definition. And there's a few things that you just kind of got to get used to with working with this. So it becomes very handy, and we'll spend some time kind of getting used to it, so it'll start to make more sense in a few minutes. So just focusing on this for a moment, so I want to just point out a few things. So this a is related to the base. Now remember, this is the same thing as a to the y equals x, and this a with an exponential is also called the base. So this is why it's known as the base, so it has to do with really its exponential form. So just something to kind of remember there, that kind of always helps me remember this. And then the other thing I want to note here is, so the way that you would say this, we say log base a of x equals y. So just practice saying that. It's new notation, so you got to practice, of course, the way that you say it a few times. Okay, so the first thing that we want to do to get used to this is just getting used to going back and forth between the two forms. So hopefully you wrote this definition down. This part here is very key. You might want to have it on a piece of paper in front of you just to kind of help you out with this. So I've got log base 3 of 81 equals 4. So if I wanted to write that then in its exponential form, this would be 3 to the 4th equals 81. So something I want to point out with this is actually true, right? 3 to the 4th is 81. So when you're trying to write this out in exponential form, if you forgot the exponential form, there's only a lot of times there's only going to be one combination that makes sense. For instance, if I wrote out 81 to the 4th equals 3, that is like not true. So that tells you that, okay, that can't be right. And same thing with like 4 to the 3rd. 4 to the 3rd does not equal 81. So there's a lot of times like only one way you can do this. Sometimes maybe you'll get unlucky and there's a way you could kind of mess it up, but most of the time I think it's going to work out like that. And then if I wanted to do that one more time with b here, so again, just using that definition, this would be 2 to the negative 3rd equals 1 over 8. So again, using what I know about negative exponents, I know that that's true, so we're good to go. So I would recommend that you pause the video here and try these two, and then hit play when you're ready. So this one's going to be 5 to the 3rd equals 125, which is true. And then this other one is going to be 9 to the 1st equals 9, which is also true, so we're good to go here. So now what we want to do is we want to go in the other direction. So now I want to write this in logarithmic form. So the thing that usually helps me, this is going to help you really figure out what this definition means. So remember, this is called the base. So this is what's going to be the base in your logarithm. So this will be log base 2, and then it's of 16 equals 4. And I kind of think about this as, like, once I start writing this down, I always think about what this means is 2 to the what will equal 16. 2 to the what equals 16, well, 2 to the 4th equals 16. You'll come up with kind of your own intuition of how to think about this definition, but that's the way I think about it. And then for this other one, so again, this would be log base 3. So log base 3 of 1 equals 0. So 3 to the what would equal 1? Well, it has to be 3 to the 0. Okay, so why don't you try these two? Hit play when you're ready. So this will be log base 6 of 1 over 36 equals negative 2. And this will be log base 8 of 2 equals 1 over 3. Okay, so now that we kind of have a basic idea of what this definition means, and you're going to practice this a lot probably, now we can talk about what is the inverse of this. So going back to this original question. So let's go through the steps again. So this is y equals 3 to the x, and then I switch the x and the y. And now this is where I have to use the definition of a logarithm to actually solve this. So this would become y equals log base 3 of x. Therefore, my inverse is going to be equal to log base 3 of x. So that's how you would actually use that to help us get to the inverse. And so from here, just as a reminder, if you're finding this helpful so far, maybe you could consider liking my video or subscribing. Subscribe, please. That really, really helps me out. Or sharing it with a friend. That also super helps me out if you are enjoying and appreciating the free math help. So I have just a few more things I want to talk to you about. So one is common logs. So these are the ones that you find on your calculator. And this is what they always mean. So if you ever see just logarithm without any number on it, this always means log base 10 of x. That's always, always, always assumed. Anytime you see just log, it means log base 10. It's because it's so common that we just drop the 10. There's no reason to write it. This other one is going to mean log base e of x. I've talked about e in other videos, so I'll drop a link to that video in the description. But this is another one that's very, very common. It gets used all the time. This is pronounced as just the natural logarithm, and that is indeed written ln, and it means natural logarithm. And it just comes up from in lots of different applications, but there's nothing special about it. It's still a log. The other thing I wanted to tell you about are just a couple of key properties now that we've already actually been using. So one of the key properties is that log base a of a equals 1. So this makes sense if you think about it in its exponential form. This exponential form would be a to the 1st equals 1. So that's kind of like duh. So anything to the 1st power is equal to itself. So this is an obvious fact. So we know this. So then if we just translate this to logarithms, then this makes sense why this is a property. And then what about this property here? So then we've also been playing around with this. So this would be a to the 0 equals 1. And actually, a lot of people forget what the 0th power is, so I'm not going to write duh next to that. But that's kind of the basic idea here. So this is a true fact. So this is what it would mean in a logarithmic form. And that's kind of all I wanted to tell you about the basics of logarithms here. So I have lots of other videos talking about logarithms. So if you're looking for more stuff, feel free to watch some more, and thanks for watching.